Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 7 now. Chapter 7 is about systems of equations and inequalities. A system is basically more than one equation or inequality, and we're looking at solutions of them, which is going to be where they cross, where they overlap, and that kind of stuff. So we'll talk about that more specifically the further along we go. Today we're doing 7.1, which is solving linear systems by graphing. Our central question is, how do we solve linear systems by graphing? All right, so let's get right into it here. A system of equations, like I said, is more than one equation. More than one equation. And a solution of a system of linear equations is an ordered pair. An ordered pair, which makes all equations true. Which makes all equations true. So, what's an ordered pair? Well, that's going to be something like 2, -1, stuff like that. It's going to be like an x and y, basically, okay? So, one way to find the solution of a system is to graph each line on the same coordinate plane and see where the two lines cross. And this point is going to be the solution of the system. So I want you to remember that for later in the lesson here, is that solutions to systems of equations are where the two lines cross, okay? So we're going to see some weird stuff where, we'll talk about more in a little while, but for now, just think about where they cross is going to be the solution. All right, example 1, it says, is 5,2 a solution to the system -x plus 6y equals 7 and 3x minus 2y equals 11? Well, for it to be a solution, it needs to be true for both equations. So what we're going to do is we're going to plug these in for x and y and see if they're true. So we're going to call 5 is x and 2 is y. And why don't you see if you can do it? Go ahead and give it a try. Pause the video, see if you can do it. Otherwise, just stick around and we'll go through it in a second. All right, so we're going to plug in these for x and y. So I have negative. I like to use parentheses whenever I plug something in. So we have 5 plus 6 times y, which is 2, equals 7. We're checking this first equation right here. All right. Now I'm going to write the rest of it. -5. 6 times 2 is 12. What's -5 plus 12? That is 7. And does 7 equal 7? It does. So this equation is good. Let's check the second equation now. So now we have 3x minus 2y equals 11. So we're going to plug in 5 in for x. So we have 3 times 5 minus 2 times y, which is 2, equals 11. Now, in PEMDAS, we do multiplication first. So 3 times 5 is 15. -2 times 2 is 4, equals 11. And what's 15 minus 4? And does 11 equal 11? It does. So what we're going to write for this, that point is a solution. And then because it's a solution, that's going to be where it crosses on the graph. If you were to graph these two lines, this is where they would cross at 5, 2. All right, sounds good. Why don't you see if you can do example 2 on your own now. Give it a try. All right, let's check it. We got 3, -6. That's our x and y. We're going to plug them into these equations here and see if they're true or not. So we have 4. Check the first equation. It was 4x plus y equals 6. So 4 times x, which is 3, plus 6, which is y, which is -6 actually, equals 6. So 4 times 3 is 12, plus -6, I'm just going to put -6, equals 6. And what's 12 minus 6? And does 6 equal 6? It does. So that equation is good. Let's check the second equation now. We have x plus 3y equals 15. Well, x is 3. I like to use parentheses whenever I plug something in so I don't confuse anything. And y is -6 equals 15. Oops. Getting sloppy with my 5s there. Okay. 3, and then 3 times -6 is -18. Okay, and what's 3 minus 18? Well, that is -15. Now, does -15 equal +15? It does not, so this is going to be not a solution. So if you were to graph these, they would not cross at 3, -6. All right, sounds good. So this is how we kind of check. So we're going to be graphing, but you're also going to want to check your answers and see if by plugging stuff in like this and seeing if they're true or not, by verifying whether it's a solution or not, okay? All right, let's get right into it now. Example 3. Use the graph at the right to solve the system of linear equations. And then it says check your solution algebraically. All right, so we had the two lines. They graphed them for us. Where do they cross? What's the point they cross? Well, I'm going to draw a little dot where they cross. Now, what's the coordinates of that point? Looks like it's going to be 3, 4. 3, 4 is the coordinates of that point. So we're going to check whether they work algebraically. So we're going to plug in 3, 4 in for x and y. So 4 is y for this first one. Times equals 2/3 times 3, which is x, plus 2. Now, what is 2/3 times 3? Well, the 3's are going to cancel out. We're going to get just 2. And what's 2 plus 2? Does that equal 4? It does. So this equation's good. Then we have x was 3 again. So we're plugging into x plus y equals 7. Plus 4, which is y, equals 7. 3 plus 4 equals 7. Does 7 equal 7? That's 3 plus 4. It does. That means it's going to work. So that's how we tell whether it's a solution or not algebraically, but whether they're both true. Okay. Now, solving a linear system using graph and check. It says write each, so we have 4 steps here. Step 1 is to write each equation in a form that is easy to graph. That's going to be y equals mx plus b. You want us to get it to y equals mx plus b form, basically. Okay? Then it says graph both equations in the same coordinate plane. Estimate the coordinates of the point of intersection, and then check the coordinates algebraically by substituting into each equation into the original system. Basically, we're going to graph them like we did over here, and we're going to check the solution like we did over here. Okay? It's nothing too crazy. So let's go ahead and graph these. So let's go ahead and do, we have y equals 1/2 x minus 2. We need to find our m, we need to find our b. Well, what's our b? It's y equals mx plus b, right? What's our b? It's going to be -2. And what's our m? It's 1/2. So why don't we graph that line here? So we have -2 is our b. We're going to go up 2 or down 2. Hopefully you remember how to graph. Yeah, we go. The b is up or down that number, so we're going to go down 2 and put a point. That's our y-intercept. And our rise over run is 1/2. So what's our rise over run? So rise of 1, run of 2 means we go up 1, right 2. Up 1, right 2. Up 1, right 2. We can also go the exact opposite direction, which we should, is go down 1, left 2. Down 1, left 2, down 1, left 2. And we're going to sketch a line. It's not going to be perfect, but it'll get the job done. And there's our first line. All right, let's check the second equation. Y equals -2x plus 3. Is that in y equals mx plus b form? It is. What's our b? Our b is 3. What's our m? -2. Okay, so our b is 3. Is that up 3 or down 3? That is up 3, put a point. And what's our slope telling us to do? It's -2, which means we go down 2. What's our run if there's no lower number? It's always over 1. We're going to go down 2, right 1. Down 2, right 1. You can see they're going to cross right there now. We could also go up 2, left 1. And there's our line. I'm going to use red to show where they cross. And the solution for this is going to be 2, -1 is where they cross. So now we got to check our solution algebraically. So let's plug into both these equations here. I'll leave it here for a second in case you need to catch up a little bit. Yep, so the coordinates of the point where they cross is right 2, down 1, so 2, -1. We're going to check 2, -1 now. So our solution should be 2, -1. We'll go check that now. So we're going to plug into the equation. So -1 is our y. We're plugging into the left equation first. So we got 1/2 times 2 minus 2. Half of 2 is 1. And we got 1 minus 2 is going to be -1. That one checks out, right? Then we have the second equation, which is y equals -2x plus 3. Well, y is -1. -2 times our x, which is 2, plus 3. -2 times 2 is -4 plus 3. And -4 plus 3 is -1. So these both check out. So that's our solution is 2, 2, -1 is going to be our solution. All right, let's do some more practice here. We're going to be reviewing how to isolate y, get y by itself, and also we're going to get some weird answers here, and you'll see what I mean in a second, but let's go ahead and get some practice here. So, it says graph and check to solve the linear system. All right, so we have negative 3x plus y equals 2. First of all, is that in y equals mx plus b form? It is not. We need to get y by itself. How do we get y by itself for this first equation? Well, we need to add 3x to both sides. So then we get y equals 3x plus 2. And now we have y by itself, so it's in y equals mx plus b form, which is good. What's our b value? It's 2. What's our y or our m value? It's 3. So we're going to graph this now. So we're going to go, our b is 2. We're going to go up 2, put a point. And our rise over run is 3 over 1. We're going to go up 3, right 1. And also down 3, left 1. Down 3, left 1. And then there's our line. All right, let's change our color here. Now the next one's a little bit trickier. We need to get, we have 6x minus 2y equals 6. We need to get that negative 2y by itself first. It's not in y equals mx plus b form, so, or slope-intercept form. So we need to get rid of that 6x. How do we get rid of that 6x? We need to move stuff away from negative 2y, so we're going to subtract 6x from both sides. Negative 2y equals negative 6x plus 6. Make sure you write it like that. Don't put 6 minus 6x. Make sure you put the x in front, because we want it in y equals mx plus b form. We don't want it to be all flipped around. Now we need to divide by negative 2 to get that y by itself. So we get y equals, what's negative 6x divided by negative 2? Well, that is 3x. And what's 6 divided by negative 2? Well, that's negative 3. So what's our m and our b? Well, our b is negative 3. Our m is 3. So let's graph this now. We're going to go down 3, put a point. And our slope is telling us to go up 3 over 1, up 3 over 1, up 3 over 1, and down 3 left 1. Now if we connect these lines here, these dots that is. Now, solutions are where they cross. Do these lines ever cross? What are these lines called when they never cross? These are parallel lines, okay? These are parallel lines, which means they literally by definition they never cross. And solutions are where they cross and they never cross. How many solutions do we have here? There are no solutions. We're going to write no solution. And we don't need to check our solution because there's no point to check. It's all, we didn't see where they cross, so there's no solution. We just can just put no solution for this one, which is pretty nice. Okay, sounds good. So solutions are where they cross. If they never cross, there is no solution. Otherwise, we'd be checking it algebraically and making sure that they cross somewhere. Okay, next one. We have graph and check to solve this linear system. We have y equals 1/2 x minus 1. First of all, what's our b? So first of all, is it a y equals mx plus b form? It is. It's in slope-intercept form, which is good. What's our b? B is negative 1. What's our m? It's 1/2. So we're going to graph this. We're going to go negative 1 for our b. Go down 1. We're going to go up 1, right 2. Up 1, right 2. Up 1, right 2. Also down 1, left 2. Down 1, left 2. Down 1, left 2. Okay. And then use our blue one here. Now is the second equation, negative x plus 2y equals negative 2. Is that in slope-intercept form? It is not. We need to get that 2y by itself and then get rid of the 2. So first thing we're going to do is we're going to add x to both sides, which is 2y equals x minus 2. Make sure to put the x in front like what I just did. Now how do we get rid of that 2? Well, we're going to divide by 2 because it's being multiplied by 2 when it's pushed together. And then what's x over 2? How can I rewrite that? Well, there's an imaginary 1 in front of the x. So I'm going to write it as 1/2 x. It's good to write with kind of the x on the side like this. And then negative 2 divided by 2 is going to be a 1. So what do you notice about these two equations? What's our b? What's our m? Our b is negative 1. Our m is 1/2. This is basically the same line, isn't it? It's the same exact line on top of itself. So it's the same line on top of itself. I'm going to do this in red here. How many times do they cross if it's the same line on top of itself? They actually cross infinite times. They cross everywhere. So what your solution is going to be, it's basically the same line same lines, which equals it crosses everywhere, which means how many solutions if it crosses everywhere? It's infinite solutions. Is infinite solutions if it crosses everywhere. So we could test any point we want, but because they're basically the same equation here and here, it's going to be the same thing no matter what. So that's another possible solution is infinite solutions. So we have one solution where you check it algebraically. We have no solution where they never cross and are parallel. And we have infinite solutions where it's the same line on top of itself and it crosses everywhere. And that's all I have for you today. Thank you for watching. Have a great day. We will talk soon.